Hello and welcome. In this video, we're going to be discussing how to solve quadratic equations by using the quadratic formula. So just as a quick review, a quadratic equation is just an equation that can be written in the form ax squared plus bx plus c equals 0. So a, b, and c are just numbers, real numbers specifically, and a cannot be 0. So our first step in using the quadratic formula to solve an equation like this is to identify what a, b, and c are for us. So a is the guy that's sitting right in front of our x squared term. So a is going to be 5 for us. B is the guy that's sitting right in front of our x term. And we keep the sign. So our b term is going to be negative 5. And then our c term is just that number sitting all by itself out here. And again, we keep the sign. So our c term would be negative 1. And then the second step is we're going to apply the formula. So the quadratic formula is just a formula that allows us to solve for x in quadratic equations, and it looks like this. So it's x equals, because again it's a way to solve for x, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So all I'm going to do is I'm going to take our a, b, and c values and I'm just going to drop them in. So we've got x equals the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c, and then all over 2 times a. Okay, now we just have a lot of simplifying to do. So let's just take this step by step. So the first thing that I see is we've got this opposite of negative 5. Well, the opposite of a negative is just positive, so we get 5. And then plus or minus the square root of. And then under the square root, if we simplify that, we could actually just run that all through a calculator if we wanted to, or do it by hand. In either case, we'll have 25, and then we've got negative 4 times 5 is negative 20. And then times negative 1 gives us positive 20. So we actually end up with 25 plus 20, which gives us 45. And then on the bottom, 2 times 5 is 10. Okay, now notice that the square root of 45, 45 is not a prime number, so there's a chance that it simplifies. So if you remember how we did this with simplifying square roots, I suggested that we try to factor 45 into its primes. So if I just take 45 off to the side, 45 can be factored into 9 times 5, and then 9 can be factored into 3 times 3, and that's as far as I can go with those factors. So 45 is really just 3 times 3 times 5 when I factor it into its primes. So we're left with 5 plus or minus the square root of 45 is just 3 times 3 times 5, all over 10. And now if I simplify that, remember how square roots simplify. Square roots are just taking half of your factors, meaning for every group of 2 factors, we can pull one out. So because I have 2 factors of 3, I can pull a 3 out. And then there's still a 5 stuck underneath. On the bottom, I just have 10. And so now all I want to do is I want to break this into my 2 separate solutions. So you'll notice that I have this plus or minus thing here. That just tells me that I'm going to get 2 solutions. So one solution is going to be x equals 5 plus 3 square root of 5 over 10. The other solution is going to be 5 minus 3 square root of 5 over 10. So notice at this point, if we just check out our two solutions, I've got 5 plus 3 root 5 over 10. So these two guys are being divided by 10. Well, notice I could do a little simplifying with the 5 and the 10, but since I can't do any simplifying with the 3 over 10, I'm just going to leave it as it is. Because if I can't simplify both fractions, then I just want to leave it as it is so that they have a common denominator. Same thing over here. Since I can't simplify both 5 over 10 and 3 root 5 over 10, I'm just going to leave them as they are. That way they've got that common denominator, and those are my two solutions. Okay, so here's another example to try. Pause the video and then give it a shot on your own, and then restart after you've given it a try. Okay, so if we look at this one, if we identify our A, B, and C, again, our A value is the guy in front of our x squared, so that's 6. Our B value is the guy in front of the x term, -4, and the C value is the guy that's sitting all by itself, so -3. And then we're going to apply the formula. So the formula is x equals opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So if we plug in our values, we've got the opposite of -4 plus or minus the square root of -4 squared minus 4 times A times C, and then all over 2 times A. So if we keep working this through, let's simplify it. So opposite of -4 is +4, plus or minus, and then under the square root. When I square a -4, I get +16. And then when I multiply these guys together, I think of this as just being, actually being connected to this 4. -4 times 6 is -24. -24 times -3 is +72. So +72 plus 16 is 88. And then on the bottom, 2 times 6 is 12. Okay, now I just want to take that 88 number and factor it to see if that square root simplifies. Well, I know 88 does factor into 11 times 8. 11 doesn't factor any further, but 8 factors into 4 times 2. And then 4 factors into 2 times 2. So if I rewrite what I have, I've got x equals 4 plus or minus the square root of 2 times 2 times 2 times 11 is how 88 factored, all over 12. So if we continue simplifying, we'll have x equals 4 plus or minus, and then notice under the square root I've got a group of two 2's, so I can pull a 2 out, and then I'm left with a factor of 2 and a factor of 11 underneath. So if I multiply those together, that's 22 all over 12. Okay, so I mentioned this briefly before, but when I look at the fraction, this guy and this guy are being, this guy and this guy are both being divided by 12. So what I want to do is basically simplify both of those fractions at the same time. So what I notice is that for this fraction, 2 is a common factor, and then for this fraction, well, 2 is also a common factor there. So I am going to reduce the fractions. So if I divide those guys both by 2, I get 2 and 1. If I divide this guy by 2 on the bottom, I get 6. So our final answer here would be x equals 2 plus or minus 1 square root of 22 is just square root of 22 all over 6. You might say, well, yeah, but couldn't you reduce the 2 over 6 further? And it's true that I could, but the problem is I can't do any more with this fraction. The 22 is under the square root, so there's really nothing more that I can do. So I want to leave it so that I've got that common denominator again. So I'll just leave it as it is. The one thing I can do, though, is write out both solutions separately. So the first one would be 2 plus root 22 over 6. The second solution would be x equals 2 minus root 22 all over 6. And those are our two answers.